Good evening, everyone. Are you able to hear me?
Yes, ma'am.
Okay, great. So, I think there is already some questions on week 9, 3, 4, 8, and 9. And you said, did you mail from exam? So, I had asked you to mail me again. I had not received your email. So, I was supposed to respond on that. Can you send me an email again? If you can do it now, I can just do it after the meeting.
Okay, ma'am.
Okay, question number 3, 4, and then 8, and then 9. Okay. So let's start with number 3 first. So Shivang is also here. So do you also have similar questions, or what sort of doubts do you have in week 9?
I got doubt only on the last question. I don't have doubt on these questions.
Okay, then maybe you can help us solve this because you have gotten the correct answers. So over here, I think the question was about what is the value of k for the above system to be stable. And when we did all of this, we just had to get x of t first. So what was x of t that you were getting?
Just a second.
Okay.
So P. Yeah, so it was x0
Mm-hmm.
e की power 1
Mm-hmm.
minus k square t.
This is correct.
Yeah, not minus, just e की power 1 minus k square.
Okay, got it. So this is fine, right? 1 minus k square t.
Yeah, yeah.
Okay. So now over here, what did we want to do? We wanted to make the exponent part less than 0, which is this part, right? So if we want to do that, it should be 1 minus k square into t is equal to 0. Sorry, less than 0. So what should happen? This part should be less than 0. So your yeah, so when will your k square be greater than 1? Only if k is either greater than 1 or k is less than minus 1, right? So was option D the correct option?
Yeah.
Okay. So is this fine, Anupam?
Yes, ma'am.
Okay. Now, the next question says that consider the same system and stability criteria. Okay. And we wanted to do what? Uh, we had to compute this part, right? Dou j by dou k is equal to 0. So we wanted to get k. Oh, let me just see. Compute k such that j is minimum. Okay, we wanted to get k. Um, yeah, so Shivang, you were able to solve this again?
Yeah, ma'am. Yeah.
Okay, so could you just guide me through this question?
Yeah, surely.
So if your j was this and you integrated it, right? So what did you get? Wait, first of all, you have to substitute some things. So your x you have to substitute from here, right? So it should be x of 0 square e of 1 minus k square square t square, yeah, plus m of u square is k to the power 4, and then x square is again x 0 square e 1 minus k square the whole square t square dot dt. Is this correct?
If we square it, then I think it should be 2t. No?
Oh yeah, right, you're right.
So t square and 1 minus k square into 2t should be there. Just 1 minus k square ka whole square should not be there.
This is fine?
Yeah, ma'am.
Okay. So now you took this out. So your x of 0 the whole square comes out.
And also 1 plus m k power 4 should also come out. So that will be easier for you.
Yeah, we can do that also. Mm, so it is just going to be this, right, inside now?
Yeah.
Okay. So what is the final part that you get?
So just the exponential part will come down, and otherwise it's -1.
No, I want the final part. Like what is
Okay,
finally? Yeah.
okay. So divided by 2 into
Hmm.
1 by 2 into 1 by k square minus 1. So k square minus 1 should be also at the denominator.
1 minus k square. Hmm.
And also -1 is multiplied. So
So this is minus, right? This is okay?
yeah.
Okay, so let me write it down like this. This is the final answer?
Yeah.
Okay. So now what do you have to do? You have to do dj by dk, right? Is equal to 0. So what is the expression that you got when you differentiated this? So it will actually be like this. So you, I mean, it was this formula, right? If it is du by, sorry. If this is in the format, you take the denominator, then you differentiate the numerator, then you take the numerator out, then you differentiate the denominator. So, Anupam, you are aware of that formula, right?
Yes,
Yeah.
yes.
Okay. Huh. So, based on that, what is the expression that you get?
Mm, mm. m k की power 4
Mm-hmm.
minus 2m k square
Okay.
minus 1.
Is equal to 0.
Yeah.
Okay. Great. So, here I think we are getting that formula, right? Mm-mm-mm. You will
Put
have to
k.
divide by 4, right? No.
No,
Go
I
on.
think just replace k square with any other variable and solve it for that, and then we will get the k.
Yeah, that's what. So, this is in that formula a square minus
Yeah,
2ab and
yeah,
something like
yeah,
that.
yeah,
Yeah.
yeah, yeah, yeah.
So even if you do that, let's say this is a square, right? So you have ma square minus 2m a minus 1 0, but I think you'll have to divide by that, right? Let me not substitute it for now. Let's just a second. It's 2k square minus 1 by m is equal to 0. So this is fine. Um, and if we do this, k square is equal to plus minus, what is that? B square minus 4ac by 2a, right? I think this is fine. So what is your k square going to be? Okay, so your b square is gonna be 4, right? Because your b is minus 2 minus 4 into 1 into what is c? 1 by m. Have they asked us to substitute values of 1 by m? No, right? Because final answer is in m. That is also in minus. So this is gonna be plus. divided by 2 into a, which is 1. So what do you get over here? 2 plus 2 by m plus minus. Did I do something wrong? Mm,
Ma'am, this K is equal to the formula what you have given written is not correct, I think. It is minus 2 root of quadratic equation is the formula is not correct, K square. It is minus B plus minus B square minus 4AC divided by 2AC.
yeah, right. Hmm. This is fine, right? I think I just missed that part. This is okay? So your k should actually be whole of this part, no? What is this gonna be? Minus b is your 2 plus minus 4 minus plus 4 by m. 2 into a is equal to 2. So this is actually going to be 1 plus minus under root. I'm missing something, right? So when your 2 goes inside, let's say this is 4 plus 4 by m divided by 4, 1 plus minus.
Ma'am, I think you are putting the wrong. B square is actually 2m ka whole square, and oh sorry, 1 by m ka should be square na. So that's why the expression is wrong. I done it using the simplifying using the Sridharacharya formula, that is there minus b directly.
Can you tell me your formula?
So I just substituted k square as p variable.
Mm-hmm.
So my expression becomes mp square minus 2mp minus 1. And
Hmm.
after that, simply that formula that you have written, minus b plus minus under root b square minus 4ac. So 2m plus minus under root 4m square plus 4m upon 2m, and then 2m got cancelled, and 1 plus under root m square under root of m square upon m, and then I just simplified it.
Hmm. Okay. So even if we do like this over here, so what is the, so when you simplified, what was the value of p that you were getting?
P value was 1 plus
Mm-hmm.
under root m square plus m
Hmm.
upon m. Only
This is
upon m is only under the under root m square plus m.
okay, got it. This, right?
Yeah.
And this m is under inside the root or not?
This expression is not, because p is equal to k square. Then after that it will
No, no,
go
no,
under.
no. I'm saying that so currently your numerator only is inside your root.
No, it is not inside. Oh, yes, only numerator is inside the root.
Correct. Got it. And then finally you do the square root again, right?
Yeah, yeah,
So I
yeah,
think for you, which one was the answer? This probably would have been your answer. Number C, right?
yeah.
Okay. So, okay, then here maybe because I did this 1 by m part. But even if I'm doing this, what is going wrong over here? Mm-mm-mm. Till here it's fine, right? As far as I think. Your b is 2, your b square is 4, and minus 4 into
Ma'am,
a, which is
actually, I
9.
think your expression is correct. Just the fact that I have divided the m at the bottom, if it goes inside the root, then it will divide the m square and
Oh,
it will
yeah.
be your expression only. Yeah, so it is correct.
Correct. Okay. Hmm.
Yeah.
Okay, and how did you decide that it is going to be plus and not minus over here?
Where?
That p. So you have minus b plus minus under root, right?
Since m should be greater than 1, na? So
Hmm. Okay. So over here also, if I do this, let's say plus, I think eventually this is also gonna become like that only. Like if I do
yeah,
4
yeah,
by 4,
yeah,
this
yeah, yeah,
is 1 plus and then 1 by m.
yeah, yeah. This is same. This.
Mm-hmm. Okay, so I think this should be fine. So Anupam, is this answer also okay with you?
Yes, ma'am.
Okay, great. So we are
Ma'am,
done with the,
I have
yeah.
given you mail. I think my mail is not reaching you. Just check it.
I didn't get it. Are you sure you're sending it to the correct mail ID?
Yes, ma'am. Whatever you sent mail is not reflected back.
Can you just verify this is the email ID because this is what is mine.
Ma'am, in that, if that mail is not correct, it sends back na your AC account that IIT wala
Yeah.
that I have mailed.
Maybe copy paste this and then send me an email.
Okay.
Yeah. Okay, let's go to number 8. Uh, Number 8 says in a safe control strategy, the CBF bx is chosen such that b dot x is less than equal to minus lambda this, lambda is greater than 0. Okay, this was given. Which of the following best describes the behavior of your barrier function and the system when bx is greater than 0 and b dot x is less than 0? So over here, this was given that your value of barrier function is decreasing over time. Why? Because your bx is greater than 0, right? And your lambda is greater than 0. So if this is greater than 0 and lambda is greater than 0, b dot x is actually less than 0, right? So your b dot x is less than equal to 0. So which of the following best describes the behavior of your system? So if this is greater than 0, even if your bx is increasing, no, bx is actually positive and your b dot x is less than 0, what does that mean? It means that your barrier function's value is continuously decreasing, right? So I think this is the right option. Bx decreases and it gradually steers the system towards safe region defined by bx less than equal to 0, because there was this concept, right? So this is the circle and everything inside this is less than 0 and that is the safe region, and if your bx is greater than 0, then that is the unsafe region. So these were the slides from there. Any more doubts here? Anupam, is this okay?
Yes, ma'am.
All right. Over here, what question do you have? This was a theoretical question, I guess. Question 9, huh?
Selected wrong option. That's
Okay, but You kind of know, right, what is the right answer, or you have some doubts in the options?
No, ma'am, I understood that.
Okay, nice. I think Shivang, you said you have doubt in the last question.
Yeah.
Okay, so which particular statement was doubtful for you?
So first one was legit. I understood it. The third
Hmm.
one was also I understood it. The second one was I didn't get in the slide. So
Yeah, this was the invariant part was not in the slide, I guess.
yeah, yeah.
Hmm. But were you able to read it elsewhere and try to answer it?
No, I searched it, but I didn't found it.
Okay. So let me check. Find out whether the following statements are true or false. This. Hmm. All sublevels of CLF are invariant. Safety boundary of the system. I think this one was true, right? What is the right answer? It should be either A or C, I guess.
All true.
All true. Okay, so option C. Yeah. So C is fine. All sublevel sets of CLF are invariant. Okay, this you may have solved because I haven't solved this. Zero sublevel set of CBF is invariant. So how did you solve the first one? I think that should be your approach for the option B also, but let me just check some proper citable version of that. So there is this one good paper. Let me see if that has this exact statement.
Ma'am, can you check it mail again, ma'am?
Yeah, this time I got it. Yeah. I'll try to send them an email like on top of yours. So it is, I guess it is a book or something like that. First, check if this link is accessible. Yes, okay. Let me just check the exact section where you can find it. Yeah, I think you should be able to get these things from section 1.a that talks about these invariance part a lot. Yeah, section 1a should be good. I did wrong selection of course, which is of last semester, but only came to know after the admit card received. Oh, you received the admit card for this year. Mm. So, Shivang, is this okay? Like the PDF that I sent over?
Yeah, yeah, yeah.
All right. So, I think one is a lot in detail, but it should be fine because it has a bunch of information over there. Okay, so is this a good time to move to week 10 questions?
Yeah, man. Sure.
All right, let's go there. So this week was more about neural networks, and I think that's evident that many things are utilizing these neural network based controllers. So this course is also having that part. So let's see. The first question is a very basic question. It is trying to evaluate our understanding of neural networks and basically the fundamental of neural networks, such as the weights, biases, and multiple other things. Okay, so we have this input layer, output layer. So basically, different layers of your neurons. Okay, so this is the most basic neural network that you can get, which has only one input layer, only one hidden layer, and only one output layer. Okay, and your output layers, I mean, there is something called as this activation function. Okay, so this is actually to incorporate non-linearity in your model. This P1 and P2 are your inputs. Okay, so P1, so it is represented in a matrix format. So if you have multiple neurons in your input layer, you will have P1, P2 all the way till Pn. Okay, and then you have your weights. So you have W1, which will be weight for the first layer, and that will be W1 1 comma 1, W1 1 comma 2, W1 2 comma 1, and W1 2 comma 2. So this is why, because we have only two neurons over here. Okay, but if you have more, there will be more connections. So what is this W1 cross 1 comma 1? It is this part. Okay, so whatever is the value over here, that gets multiplied by this, and then whatever is the value over here, that gets multiplied by this part, and then both of them sum up over here. All right, so that is what is given over here. If you have more such connections, like more neurons in the hidden layer, you will have like a bigger matrix over here. Similarly, you will have your W2 also, right? You have W2 1 comma 1, W2 1 comma 2, W2 2 comma 1, and W2 2 comma 2. And then you have your biases. So your bias is also represented in a matrix format. So your B1 is actually B1 1 and B1. How is this represented? Okay, B1 2 like this, and then your B2 is actually this B2 1 and B2 2. Okay, so these are the things, and finally your output is Q1 and Q2. All right, so these are the different terms that are being used over here. All right, so what is the question? All these values are given to you. Okay, so all these weights are given. These are the four weights for your W1. Your biases are given over here. Your W2 is given over here, and your B2 is given over here. So select the weight matrix for the output layer. What is your output layer? It is over here. So what is the weight layer for weight matrix for that? It is W2. So you actually have to just get the value for W2. That is going to be your answer for this question. Okay, so this was a very straightforward one. You just substitute the values and you should be able to get the answer. Let's see the next question. Which of the following are the expression of the logistic sigmoid function given a m minus 1 as the input to the function? Can you tell me what is a sigmoid function? How do you represent f of x if your f is a sigmoid function?
1 divided by 1 plus e to the power minus x.
Okay, so the question says find out this. Okay, so I think this also should be solvable. Yeah, we should be okay. Okay, so the next question is considering logistic sigmoid function as the activation function for a controller designed using NN in question 1, find out the values that are passed to the output layer when the input state vector is this. So what is this input state vector? This is your P, 0.2 and 0.5. Okay. Just a second. Yeah. And then you have your weight matrix W1, right? Your bias is also there, which you get from question number 1. So now what do you do is first you calculate Z1. What will that be? W1 into P plus B1. So you have your weight matrix and then you put 0.2 and 0.5 plus B1 you put. Okay. Since B1 is not involved in any question, let's just do it. So what is B1 over here? Can you guys help me? And even B2.
B1 is 0.25, 0.25,
Okay, and what is B2?
0.35, 0.35.
Okay, nice. So these are the two things. So B1 is 0.25 and 0.25, right? And your B2 is 0.35, 0.35. Okay, so over here we will do 0.25 and 0.25. So finally, when we solve all of this, we will get a vector for Z1. Okay, now what are we going to do is, we will use the logistic sigmoid function, which is over here, for both of them. Okay, so you already know this is 1 plus e to the power minus x, and what are you going to do is h is equal to sigma of z of 1. Okay, so then you will, whatever values you have, you just substitute that in this function and then you get that value. So now you will have your h. Okay, so next what we have to do is, we also have w2 over here, which you are getting from the other one. So just for exercise, let's do w1 because that is not being asked in the question. Could you help me? What is w1 matrix?
0.1, 0.3,
Hmm.
0.2, 0.4.
Okay, great. Okay, so the same comes over here and then you do it. So this part goes over. No, that doesn't go. Okay, so that is fine. So next what you have to do is, you have to do Z2, and that how will you get? You do W2H plus B2. So whatever you get over here, you have to multiply that with your W2. This comes over here plus 0.35, 0.35, and finally what do? your answer is going to be sigma of Z2. Okay, so this is what you will get, and that is going to be your answer. All right. Let me know if you have any questions here.
Ma'am, how to put this x value, which is a column in
So
E?
let's say over here you got 6. I'm just giving an example, okay? Don't consider this as an answer. Let's say you have 6, right? So your sigma of 6 is going to be 1 by 1 plus e to the power minus 6. You will calculate this, okay? And that will be the first value over here. And if you have something over here, you will then substitute the same in the place of x, and you will get the second value. So now you understand how to use this function.
Yes.
Okay, we'll move to next question.
Yes.
Okay, so let's see what is this question about. This says sensitivity of the squared error or loss function of a neural network with respect to its net input of mth layer can be expressed by this. Fill in the blanks appropriately. Okay, so I think this is somewhere here which describes the derivation of your loss function and how, based on the change in learning rate, you change your like your weights change based on that. Yeah, so this is your back propagation. I think that comes in the start of back propagation. Mm-mm.
Ma'am, page 13, I guess it is given.
14. Mm,
Oh,
yeah. So I guess all of you understand how back propagation works. So this is more of sensitivity in that term. So you have sensitivity of this particular layer, and that can be propagated to the mth layer like the following in any kth step. Okay, so this is given over here. You have your sensitivity, which is dou f by dou nim, right? This is I is like the iteration. So the question is exactly the same. You have to get for the mth layer, okay, and the sensitivity with respect to its mth layer, which is exactly over here, right? So this exactly does all those derivations and stuff, and then you get this particular equation, or I would say terms. Okay, so the first one is already given, which is s of m plus 1. I ignore I because I is based on the, the iteration or the neurons basically, so you can ignore that part. The last two you have to fill it, so you can take help from here. And yeah, I guess you can ignore this also because eventually that's like a weight matrix altogether. And then make sure that this is f dot and not just f, so you'll have to differentiate it also. Okay, so this is yeah, I think this is again the theoretical, so I will write refer slide 14. Okay, let's move on to the next one. Any questions here, by the way?
No, ma'am.
Okay, so let's go to the next question. Yeah, this one is again a numerical type. So for the neural network given in question 1, okay, calculate the updated weight. This is the value that we have to calculate in the first iteration for the learning rate alpha is equal to 0.25. These are your target values and these are your actual outputs. So approximate the answer to two decimal places and hint is all of this. Okay, so this is where that thing comes into picture about the learning rate. So in the next iteration, what happens is you take the value from the previous iteration and then you subtract it with this value. And what is this? This is learning rate into dou f by, I mean, the rate of change of your loss function with respect to that particular variable. Okay, so this is the variable that is being used over here. And how do you calculate this? I hope this is visible to all of you. So this variable is calculated as dou f by dou of a1 square. Why did we take a1? Because we are going from output layer back inside the network. That's how we are back propagating. And then a1 by n1 and then n1 by this weight. Okay, and then your this is the loss function that is provided to us, which is qt1 minus q1 square plus qt minus q2 square, and this all is given. So let's just start solving so that we know. And a1 is coming from question 3, which is your logistic sigmoid function, and these are all the weights and biases, everything are coming from your um, first question. Okay, so let's see. Mm, yes, so my alpha is given as 0.25 and your W1 of 0, that is given as how much? 0.5. Okay, so what is your target output? 0.15 and 0.95. What is the actual output? 0.73492, 0.77955. Okay, and A12 that we got from question 3, the value of this one we have to get. Okay, but wait, is the input state vector same over here? Yeah, they haven't said anything, right? Okay, so we can take the value whatever we get from here. This is your A1. Okay, so that we have to get over here, A1 of 2. Okay, so you get the second term that you get from the answer of question 3. So if your A1 is this, then you have to extract out this part. Okay, or is it the first one? One second. A2 of the first one. How's the naming convention? A2 of 1, so it is going to be over here. Okay, so the first, you should actually take the first term. Okay, Okay, so take that value. And we have our loss function, which is given as q1 of 1 qt1 minus a1 cube. Okay, so this is entirely this stuff, and this is given as this. Okay, so I'll just simplify it for you. You will get it like this. Okay, q1 minus a11 the whole square plus q2 minus a21 the whole square. Okay, and this a1 is also from the previous question because you got a1 also over there. Okay, so this was a2 which you got from question 3. This was your a2 actually, and this should be your, I mean, I'm writing it as h, but this is your a1. Okay, so that is the output of the first layer, and this is the output from the final, like the output layer. This is the output from the hidden layer. Okay, so you take those values over here. All
Ma'am,
right,
the
the first one.
T is 1.
No. I'm simplifying it because this is a like a long equation, and then you have multiple
So, ma'am,
substitutions.
in that F, there is a T, T1 and T2 also, no?
Yes.
In the loss function, what is T1 and what is T2?
Hmm. Just a second. Your n1 cube, you put it over here, and then a1 cubes, you put it over here. I think they are referring to this only. This Q that we have. Hmm. We have only one Q, right? Which is the target outputs. Maybe they mean by the different iterations, but over here, since we have only one, like we have only one Q value, right? So that should be okay. So don't worry about that equation. I mean, you can put these two values. The target, they also mean the target values only. Okay. So QT1 is actually equal to 0.15, and this QT2 is 0.95. Okay. So how you will be proceeding with this is the next one is, so this is how you got your loss function. Okay, these are the different initializations in your problem. So the next step what you do is you will be computing your gradient components. So here you are actually going to use that formula of the learning rate. Okay, so here we have W2 of 1 comma 1 is equal to W2 of 1 comma 1 0 minus alpha of dou f by do w1 comma 1 of 2. Okay, and this is actually what? This particular part. This is dou of f by dou of a11 into a11 by n12 into n12 by, this is the chain rule that is being used in your backpropagation. So the first one you will compute first. So let's say dou of f by dou of a of 1 1. So this is your f, correct? This is your a11. So you are just going to be with this one. This is a constant for your a11, that's not even a variable. So this part becomes 0 when you differentiate it with respect to a11. Okay, so what is the differentiation of this with respect to a11? You are going to get 2 of q1 minus a11. Let me write it properly. Okay, into minus 1. So minus 2. Okay, so you just substitute the values that you have. A1 value, you know, a11 because you got from the previous question, question number 3. The first row of a1, which was your h also, and then q1 is this 0.15. Okay, so your 0.15 minus whatever values you got from there that you put here, so you got this value. The second term is what actually? Dou a11 by dou of n1 square, and that is given as what? So what is your dou a11? That is your activation function, right? So this is given as 1 by 1 plus e to the power minus n1 square. Okay, and this entire part you differentiate with respect to n1 square. So finally you are going to get a11 1 minus a11. This is like I mean, if you have a logistic sigmoid function, there is a very straightforward equation of the derivation of the sigmoid function, which is this. So if this is your sigmoid function, the derivation of that is actually x into 1 minus x. Okay, so that is what I have put over here. Okay, and that's how you will get it. So a11 you know, which is 0.73492. Yeah, and 1 minus 0.73492. So that you get from here. Mm, yeah, what more do we have? The third one. Let me just add it. The third one is dou of n1 square by dou of w1 comma 1 square. Okay, so what is your dou n1 first of all? Hmm. Actually, it should be n1 square over here. This part. So let me just write it. So you should take n1 square like this, w11 square a1 square plus w21 square a2 square plus b1 square. Okay. So if you want to differentiate it with respect to w11 of 2, it's not square, basically 2 of that part. So you will get what? A1, A2 of 1, right? So that you put the value over here, which you get from question number 3. Okay. So once you have those three, um, what do we get? We multiply all of those three, right? So you multiply this part, and this part also. So Q1 and A1 of 1. A1 of 1 is actually your this part, 0.73492. Okay, you calculate that. Over here also you calculate the same thing, because A1 also you know, 73492 into 1 minus 73492. So let's say this is your A, this is your B, and this is your C. Hmm. Okay, so you take A into B into C, all right, and then what you do is, what was your weight value? W2 of 1 comma 1 of 0. This was 0.5, right? Your alpha was 0.25. So you have to fit in the equation 1 comma 1 of 1 is equal to 0.5 minus 0.25 into, let's say this is equal to D. So you will put D over here. Alright, and then you will get your answer. Yeah, I think this should be fine. A2 of 1 you can get from here. Mm, yeah, whatever answer you get, so the first value you pick from here, A2 of 1, that is going to be the value of C. Is this fine?
Yes.
Okay. Yeah. Also, I'm not sure. So, Anupam, you had this question, right, about QT1 and QT2. So, you can check if it is there in the slides somewhere. But this one is like the very simplified equation that I have written based on what is your target and what is your actual. So, your loss function is actually that. So, I have done this minus this the whole square and this minus this the whole square. So, that's what is given over here. Okay. So, yeah, you should be able to do this. Let's check another question. Number 6. Okay, this is again a theoretical question, but please don't make mistakes while you solve these questions. So, one is imitation learning, reinforcement learning, and supervised learning. So, just for briefer, can somebody tell me the definition of supervised learning?
I mean, supervised learning, we give the known values
Mm-hmm.
to train the neural network. Known
Okay.
values, uh, and we see the output, and then we see the difference.
Okay.
That is the supervision.
So difference meaning the loss, right?
Yes, yes.
Okay. So in supervised, you know what is the target output, correct? So what is reinforcement learning?
Reinforcement learning, that that function is either it will, okay, give reward or give the penalty. So
Correct.
that
And you want to do what in the training?
that we will, okay, reduce the error.
No, there is no reducing the error. There is either maximizing the reward or reducing the penalties, right? So either of that. I mean, error is a very broad term. So in supervised learning, you have your loss function, right? Which you try to minimize. That's what we just did right now over here. We are trying to minimize your loss function. Okay. In the reinforcement learning, you have your maximizing your rewards. What is imitation learning? Okay. So if you would understand, let's say, these self driving cars or drones in general, okay? So if, let's say, this is the images that are being captured by the onboard camera, okay? So either by UAV or, cars or anything, any autonomous vehicle. So this is just an example that I'm giving you. So what happens is, first of all, you start a drone. Let's say this is a drone and this is your entire arena. Now you have some kind of obstacle somewhere here. So based on what kind of visual images are coming in, there is a person that is flying the drone first. Okay, then the model records whatever the person is giving in the controls, and it does that. And the next time, if you get the same kind of visual, it checks if there is a similar control like that and it implements that. So you first learn and then you imitate the same kind of thing. Okay. So when we do imitation learning, we do one set of run by the driver, like even if it's if it's car, right? So based on whatever is in front of you, based on that, the angle by which you move the steering wheel and all of that, so the model tries to learn those things. So over here the model tries to learn the kind of behavior that a person would do, and it tries to do that when the system is actually autonomous. So this is what is imitation learning in general, I would say. Okay. So I think based on these you should be able to answer these three questions. Is this okay, or any questions over here?
So in that case, imitation learning,
Mm-hmm.
it is required a trained teacher like thing, like second option.
Yeah, right. Okay, let's go to the next question. This is like a power plant model, and over here we are trying to understand that which of the following statements are true for the above adaptive controller. So over here you see a few things. This is your NN controller and this is your adaptation algorithm. So adaptive controller is actually your controller along with your adaptation algorithm. That's what your adaptive controller is. This is your input that is going on, and this is the reference model which is there. Okay, and somewhere over here you are doing the error calculation, because this is the exact command input that is going on. This is the reference model, this is the actual model. Okay, so this is where the error calculation is going on based on this plant output. Okay, now another thing is, this is the plant, some kind of noise is also there, these are the sensor noise and everything, and this is your neural network plant model. So again over here also some kind of noise um, error is going on. You have your NN inverse plant model. So this is what is the compensation for your noise that is going inside your plant. Okay, and then this is your tracking error. So these are the different kinds of thing over here. So which one is actually true? So first statement says as, okay, and over here you should choose multiple options. As the tracking error increases, the controller becomes accurate, or as the tracking error decreases, the controller becomes accurate. So tracking error is this one, right? Which is going inside your adaptation algorithm. I think that is the one, right? Okay, no. So the tracking error is actually for this one. Hmm, you should place it a little on above. All right. What I think this is your error, because this is plus and minus. Um, yeah, based on that, it is actually adapting. So what is this error actually? One thing is what the plant is giving, and one is that your reference model is giving. So based on this reference model's output, which should be the ideal output, and then you are getting something output which is from your neural network. Okay, so if so, when at what point does your model becomes accurate? When the plant output is actually equal to your reference model output, right? So you have to choose the option where if your controller is accurate, that means that your error is equal to 0, right? So you have to check that if your tracking error decreases, then is your controller accurate, or if it increases. So out of these two, only one is correct. Okay, and then the second part is compensation for noise characterizes the error in the output caused by only the process noise. Compensation for noise, it characterizes the error in the output, okay, caused only by the process noise. There is a process noise over here, there is a sensor noise also. Compensation for noise characterizes the input required to reduce the error in the desired output caused by the sensor and process noise. Yeah, so you will again have to check, because whatever is going inside your model, the plant model, okay, so what is this compensation for noise actually? So there are two things coming in, right? One is from your sensor noise and one is the plant also. So you'll have to check that also. So out of these two, again, one of them is correct. Okay, so were you able to understand this diagram first of all?
Yes, ma'am.
Okay, nice. Should we move to the next question?
Yes.
Okay. Which of the following statement is correct regarding the control barrier function when designing a safe controller using a neural network? Okay. So over here there is only one question. This is again of that similar concept that your, I mean this. barrier function has to be less than 0, right? It has to be inside this circle region. So your CBF must remain positive inside the safety region to ensure safety. The rate of change of CBF must be positive. The CBF must remain in negative. And the NN agent should reward control inputs that make the CBF positive. Okay, I'll give you a very straightforward answer to this. Where is your week 9? It's exactly related to this question number 8 over here. Okay. So if you know the answer to that one, you should be able to just um, pick the option for this question. Moving on. Okay, this one is reward penalty schemes. Which of the cases will help in designing a stable neural network based controller? This is again multiple choices, so multiple options are correct. So the controller, what should it do? It should penalize the agent for generating such control input that change the future state such that the eigenvalues of discrete time closed loop state transition matrix approach 0 inside the state space. Or should it reward the agent for generating such control input that change the future state such that... Okay, so I think out of these again, one are correct over here. So the question over here, it says that do we need the eigenvalues to be equal to 0 or not? Okay, so this eigenvalues of the state transition matrix, which was your A. So if we need the state transition matrix to be 0, if the answer is yes, you should choose A. Sorry, you should choose B. If the answer is no, you should choose A. Why B and A? Because if we need this and we are rewarding the agent for getting this, which means that we are supporting that, right? We are supporting the agent to get some kind of eigenvalues which is approaching 0, right? But if we are not supporting it, which means that we are penalizing the agent for approaching 0. All right, so that is the gist of that particular question. What is the second part? It says it should penalize the agent for generating such control input that change the future state such that the rate of change of CLF becomes negative around the equilibrium point. Or should it reward the agent for generating these inputs so that rate of change of CLF becomes negative around the CLF point? Again, over here, do we need, how do I write that? So differentiation of your, so let's say your CLF function is f. Okay, so do we need f dot to be less than 0? If it is yes, you have to reward your model, which is you have to reward your agent. If you don't want to reward your agent on that, you penalize the agent, which means it is C. So these are the, this is basically the question. Is this fine?
Yes.
Okay. So this is also done. Yeah, last question. State whether the following statements are true or false. a trained neural network based safe controller does not guarantee safety. The primary purpose of the activation function in a neural network is to introduce linearity into the model. So about this part, when I was explaining the neural network and why is an activation function used, just pay attention to that, and that should help you solve this question. Or in general, just go and look at the definition of activation function and as to why it is used for any of these layers. Like whenever you get an output, right, you pass it to a activation function, and whatever you get out of that activation function, then you pass it on to the next layer. Okay, so
Ma'am, the first one is the trained neural network does not guarantee any safety.
hmm.
How this trained will give the guarantee?
Don't ask me. I mean, if there is no guarantee, then you should choose that it is a true option,
But my point is any okay neural network
right?
it will not never give guarantee. Okay, it will give
So
the
there
error.
will be some kind of probability, right?
Yes, yes, yes.
So you have to think in that term. Yeah.
In the true speaking, okay, it will never give guarantee. That is what my question. There may be okay 0.01
Hmm.
where it
Yeah.
will
So
fail.
if it cannot guarantee you a safety, then you should pick the true option.
Yes,
Okay.
yes.
Yeah. Okay. I guess this is it. So yeah, let me know if you want some me to like revise some other question if required. Otherwise, we can close the session formally. So yeah.
Ma'am, what it
Yes.
happened, I will just brief you. I have
Mm-hmm.
registered for 5 courses, but
Okay.
unfortunately, 6 months on in the month of December. Okay,
Mm-hmm.
Unfor- unfortunately, I missed this registration, this course, and
Okay.
selected the wrong one, which the
Hmm.
exam happened on 23rd of March. Okay,
Hmm.
so on before the 23rd March, I got just an admit card. So because that was the last what you say semester exam which I missed. Okay.
Hmm.
So now in the entire 6 month, NPTEL doesn't give any messages or that you have registered for this and submit the assignment or take the class.
Hmm.
So it is a system error, what I told to them. See, if I have registered for exam, just check it whether I am eligible for that or not. Because giving exam is not a what you say only option. You have to submit assignments also, na?
Correct. Yeah. Right.
So now if I have registered for
So
any
have you
course,
registered for this course NOC 2532?
this course which we are going,
Yes. The
yes,
code
yes,
for that is NOC
yes,
2532, right?
yes, I have
So you have
registered,
registered for that. You are
but
submitting all the assignments also.
yes, yes, but unfortunately, because messages are coming, because announcements are coming, okay.
Yes.
So that is why I am submitting now the error what it happened. I have selected the wrong course. So that is why the announcements and assignments, okay, they are not coming to me. Suddenly exam admit card came. And
No,
then
no,
I
no.
thought that
My point is for this question, for this course I'm asking. So for this
yes, ma'am.
course, are you registered?
Yes, ma'am. I have
Okay,
registered and submitted.
you are registered for this course with course code
Yes, ma'am. Yes.
NOC 2532, right?
Yes, ma'am.
And
Registered
you have
and
submitted all the assignments till week
yes.
10, like week
Yes.
9.
Yes,
Okay,
ma'am.
then you do one thing. Whatever you have mailed me, you just put that, just reply on that. Okay, and say that you have registered on this using this email ID, and
Yes, ma'am.
if you have gotten some kind of proof that you have registered, you should
Yes, ma'am.
attach that also. Okay, so do
Yes.
that,
Yes.
and then
Yes,
I'll
ma'am.
reply to them. So all these things, don't tell them because they might get confused. We'll just tell them what
And
we need
ma'am,
to
the
be done.
city in which I am giving exam, na, the center
Yeah,
is
but
always
they won't care about that, right? I
no,
mean,
no. But the problem
yeah.
is they say ki that they have fixed the center. But my submission is only 5 to 6 okay candidates are there in my center. Always, it is always okay
See, but
underutilized.
they had given you a deadline. They were sending multiple reminders, so it's
I know,
definitely
ma'am.
going
See,
to be
this is error
positive.
from my side also. I am not
Right,
saying
right.
that I am.
Yeah.
But
So
if we
let's
can,
do what is best possible
yes, ma'am.
approach,
Yes.
and let's wait for their response. Okay.
Thank
So I
you.
would
Okay.
suggest you whatever I asked you, right? You put the
Okay, I
registration
will give
number
you,
there.
ma'am.
You put all the emails details over there. We'll try to
Okay.
get a response from them.
Thank you,
Okay.
ma'am.
Yeah. All right. Okay, Shivang, any question from your end?
No, man.
All right. So, yeah, best of luck for your assignment, both of you. Please do well. We can meet next week, Saturday, same time. And Anupam, please send the email so that I can revert back on that.
Okay,
All
ma'am.
right.
Thank you.
Yeah. I'll be here until 8 p.m. if any of you have any doubt. But yeah, thanks for attending the session.
Thank you, ma'am. Thank you.
Thank you, man.